Here with me, I have a stack of cards that contain DevOps interview questions and their answers. But in this video, I'm going to give you not only what the answers are, but why that's the right answer. And I think that's really, really important because as soon as you land your first DevOps job, you don't get posed with problems that follow a predefined format. And so understanding why certain things are done certain ways is going to make you successful in the long run as a developer. Hey, what's going on? I'm Will from DevOps for Developers. And on this channel, I talk about everything DevOps related, whether you're preparing for your first DevOps job or whether you're integrating DevOps throughout your entire team. So we're going to go through these questions. I've got a bunch of them here, so we may break it up into multiple videos, but let's just jump right into it. First question is, what are the different phases in DevOps? All right, now the answer here is planning, development, CI or continuous integration, automated deployment, operations, and monitoring. So let's not memorize that. Let's just think about when you're doing something. And it doesn't matter what it is, whether you're building a car, baking a cake, making a rocket, flying it to a foreign planet, whatever, you always go through the same steps. The first step, planning. You've got to decide what it is you're going to do, right? You can't actually take action until you have a plan. The next stage is development, or actually start to do the thing, build the product, build your workflow or your tools or whatever it is you need to do, and grab the ingredients to bake the cake and put them all together if that's what it is you're doing. The next stage, continuous integration or CI. And this is kind of like the QA check along the way. If you're building a car, at some point you're going to stop before you send this thing out to the customers and make sure, do the blinkers work? Does the horn make an obnoxious noise? Do the wheels go round and round? Those kind of things. Continuous integration. The next stage is automated deployment. Well, if you've built this thing, you've got to get it to the customer somehow. We're going to do that in an automated fashion. But regardless, there's a process of getting it from the people who built it to the people who are buying it. The next part is operations. So you've got this big whole pipeline or workflow or factory, whatever the case may be, that builds your product. How you get people and products into that and out of that on the other end is operations. And then the final one is monitoring. And the monitoring is kind of like the checks part of your checks and balances, right? If no one's looking for smoke, you're never going to know when something's on fire. That's monitoring. All right. So don't sweat this question. You can overthink it, but really it's just the same process and pattern that you would use for solving any problem. It's just in this particular example, the problem we're solving is DevOps. All right, next question. Why has DevOps gained popularity in the past few years? So there's probably like a couple answers here, right? The big thing that you want to focus on is it makes the engineer's life easier, right? Why are they put up on a pedestal? Well, because they're the biggest obstacle between getting the software product that we're building out the door to our customers. And so anything we can do to improve that process, to make that process faster, is going to help us out. So if you go back a couple decades, the Japanese really mastered this process of building automobiles called Kanban, or just-in-time manufacturing, so that parts needed to assemble the cars showed up just right before that they were needed, which meant that they didn't have these huge facilities storing all this stuff for someday production. That really revolutionized how cars were built. First in Japan, which gave them a huge lead over car manufacturers around the world, and then other car companies adopted that and finally caught up to them. That's all we're doing here with DevOps. This is just changing how we build software into a more lean, efficient, faster, iterative method. All right, the next question we're going to cover here is, what's the difference between Ansible and Puppet? Now, I kind of like this question because in order to answer this question, you've got to, first of all, know what Ansible is, you have to know what Puppet is, and then you got to know why you use those, right? So those are used for configuration management. Whenever you build out a server, you've got certain pieces of software that are installed and configured on that. And Ansible and Puppet are two different ways of managing that software. So the key difference is Ansible pushes the changes out to the server. It's written in Python and uses YAML files. It has this backend server called Galaxy that it can use to orchestrate everything. And the key thing here, the most important one, if you forget everything else I just said, the key thing is that it's agentless, meaning you don't have to install anything on the server being managed for that to work. Puppet, on the other hand, is an agent type application. So the first thing you have to do whenever you manage a server using Puppet is go to that server and install the Puppet agent on that. And so that's a pull type model. So once that agent's running, it will check in with the server every 30 minutes, or you can configure it to whatever it needs to be. And it will say, hey, what's my state supposed to be in? It'll get that from the server and then make the changes necessary to make sure that that's how it actually is. Other trivia type facts, it's written in Ruby versus Python. And then there's this thing called the Puppet Forge where you can get all types of different common configurations so that you're not building everything from scratch on your own. But the key thing there is to know that these are for configuration management. And the most important difference between the two is Ansible pushes the changes out. Puppet will pull the changes from the server being managed itself. And that takes us right into our next question. What is the purpose of configuration management? I kind of touched on this a little bit in the last question, and it's consistency, documentation, automation, control, and implementation. And really all of that boils down to if you have tens of servers or hundreds of servers or thousands of servers, you can't be logging into each one of those individually and making changes to them. Think about several years ago, there was this vulnerability called Heartbleed, where every Linux system on the face of the earth was affected by this vulnerability. And so all of those had to be patched. If you were managing thousands of servers, that meant you were going to log into thousands of servers and run this update to patch that vulnerability. Configuration management allows you to manage servers at scale. You could tell your configuration management server, hey, push this patch out, and boom, it does it. All right, our next question. What is a merge conflict in Git? Now, this one seems kind of specific, but I really like where they're going here because in order to answer this question, you have to understand what Git is and how Git is used. And that's really important because a lot of your interaction as a DevOps engineer is going to be interacting with the software engineers who are building your application, and they use Git for their workflow, or they should be. And if they're not, you're educating them and building out the systems so that they can. In addition to that, though, you should be, wherever possible, treating your infrastructure as code. And when you treat your infrastructure as code, you're going to have your infrastructure code checked into a Git repo, and you're going to follow the same processes that the software engineers do, where updates to that are done by checking out the code locally, making a change in a feature branch, pushing that feature branch up to the Git server, opening a pull request, doing a review with your peers on it, and then merging that into master. So throughout all of that, if two people have changed the same file, that's what creates a merge conflict. In a lot of cases, Git can see those changes on the same file and just merge those two together. Sometimes it encounters a situation where it doesn't know whose change is right, and that's when it throws up the merge conflict. All right, the next question is, what are the benefits of DevOps? And I want to break this down into two different parts of the answers, part A and part B. First, we have the technical benefits, and then we're going to talk about the business benefits. So now the technical benefits revolve a lot around automating the developer or the engineer's workflow so that when they make changes, they check it in and the tests run automatically. And then once that's merged into master, it could be deployed automatically. Rollbacks are easily done so that you can roll back whenever things go wrong. And just from a technical perspective, it gives you a lot of safety and a lot of flexibility so that you can just do things knowing that you're able to safely fall back if things go wrong. Now, the business benefits is why that's really important, because from a business perspective, it allows the business to act more boldly. For example, if they know that these technical benefits are in existence in the engineer's workflow, they can go and say, well, let's just try it and see what happens. And if it fails, we can roll back. So that gives the business the ability to be more bold and take bigger risks because they can fall back from them safely. And a company that's able to take bigger risks more safely can develop a competitive advantage over everyone else in that field. And then that leads to more success for your business, which makes the business more profitable. And in theory, that profit's going to turn back around, come back to you as an employee of that company, and that whole cycle there. So those are the two benefits of DevOps. All right, next question. What is a VCS, or version control system? So the purpose of this question is just to understand, or just to gauge your understanding of how something like Git works, right? So I would expand upon that, because you can answer the question, what is a VCS? Well, it's a version control system that allows you to track versions or changes made to code over time by who made them. Great. Who cares? Well, the reason we care is because it allows our developers to make branches and build out their code and then safely merge that back into the main branch, so that we can track where work is happening and where it came from. And in the event that something goes wrong, or more truthfully, when something goes wrong, period, we have a path back to see how that code was introduced in the system. And there's a key point here. We don't care about how that change was introduced for the purpose of blaming someone or hanging them out to dry, but only to understand what happened, where's the weakness in our system that allowed that person to make a change that they shouldn't have, right? So if somebody makes a mistake in production, and I'm getting way off topic for this question, but I don't care. If somebody makes a mistake in writing code and that makes it out to production, I don't care. It happened. We've all made mistakes. The only thing I care about is understanding the steps that led that to happen, because I should have had a system in place that identified that that was a breaking change through an automated fashion before it made it into production. So my only concern there is figuring out, is that something that I can monitor for and prevent happening in the future, not because a mistake was made, but because I want every engineer on my team to know that they can do things and they don't have to be these infallible humans that never make a mistake, because we have the checks and balances in place to protect them along the way. But that's actually a really good segue into the next thing. What's a postmortem? Well, outages are going to happen, and outages are just a fact of DevOps life, and it's a fact of engineering life too. Sooner or later, your site's going to go down. And like I was just saying, a postmortem is an analysis of how that went down, not for the purposes of identifying the person who did it and ridiculing them publicly and then firing them and then throwing them out the second floor window with all their shit. It's not for that. It's to understand where the weakness in the system that I built was that didn't catch that there was an error going into production. All right, next question is, what is Gitops? I'm just not going to lie here. I am extremely disappointed that Git is such a common word in software engineering, yet nobody knows who Larry the Cable Guy is. It's quite honestly a little bit of a tragedy, because I can't even use the word Git without hearing Larry the Cable Guy say, "Get her done." But Gitops, well, that's the ops side of getting her done, right? Gitops is, we've talked about multiple times about software engineers, how they write their code by checking out the code from the repo, creating a feature branch, writing their code in that branch, pushing that back up to the Git server, opening up a pull request where it's reviewed by someone else on the team, and on approval, that's merged back into master, where it's eventually deployed out to production. And now in modern software engineering, a lot of our infrastructure is driven by code as well. If you're using any of the cloud providers, AWS, Azure, Google, or you're using something like Kubernetes, your entire infrastructure is driven by code. When you want to deploy a new service, you don't buy a server and install it in a rack, and install software, you create a YAML file that defines how that service should work. The key thing there is you defined a YAML file. Well, that's code, and that code can now live in a repo. And if it can live in a repo, whenever we want to deploy a new service, we can check out that repo, create a branch, build out that service in that branch, submit that back to the Git server, open up a pull request, and then have our team review that to make sure that it looks right, and then deploy that out to test, development, staging, and production environments, so that the process of building infrastructure follows the exact same workflow as the process of building applications, and that's Gitops. All right, I got a whole bunch more questions, but this video is getting kind of long, so we're going to call this video here, and stay tuned for part 2 of this video series where I go through and take a look at DevOps interview questions along with the right answer, and then tell you why that answer is the right answer. So I'll see y'all in the next video.